Hey everyone, welcome to the lecture for 2.5. We're going to talk about measures of center, mean, median, and mode. So they're called measures of center for a reason, and it's just a way for us to describe kind of where the middle of the data is. And we've seen a little bit of that before when we talked about median. We're going to dive in a bit deeper today. So the three measures of center are mean, median, and mode. So mean is the arithmetic average of the numbers. That's where we just add them all up and then divide by the number of things that we added up. The median is the middle data value, which we discussed previously. And the mode is the data value that occurs the most frequently. So let's start with an example of the mean. Before we do that though, there's actually two means that we have to talk about. They both look and smell and quack the same. They're both the arithmetic average, again, adding them all up and dividing by the number of data. And I should also add that most of the time when people say, oh, what's the average of blah, 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 they're really talking about the mean. But technically all three are averages. So the two means are population mean and sample mean. So we talked a lot about populations and samples and their differences previously. When we take the mean of a population, we call it mu. When we take the mean of a sample, we call it x bar. So why would we bother naming these two different things? The reason is when we get into inferential statistics, what we're wanting to do, or the aim of our studies here, is to be able to take a sample, from the sample, say things like, based on our sample, we think the population mean is this, or based on our sample, we think the population standard deviation is this. So typically X bar is a statistic, right? It goes with the sample and it's used to estimate or approximate the parameter, which is belonging to the population, right? So we have population and parameter, those two go together. And then we have sample and statistics, so those two go together. So mu is a parameter and X bar is a statistic. They're both calculated in very much the same way. We call them different things and one of them gets a capital N. You'll get used to it. All right, so the sample mean, X bar. 10 children are sampled to determine the average, the mean number of candies collected on Halloween. The data are recorded and now we want to find the sample mean. I would like to add this is a terrible sample because it's very small. And again, we'll discuss good samples and bad samples later on in the semester. All right, so the way we're going to do this is we're going to compute sigma x. Sigma x just means add up all the values. So if we add up all the values, 70 plus 70, 72, etc., until we get to 97, then 99, we would get 833. Next, we need to know our sample size. So first of all, it's given to us in the statement of the problem, but if it hadn't been given to us, we would have been able to simply just count the number of data values we have. So we find or read that n is equal to 10. That's the size of our sample. So we just divide the sum of our data by our sample size, which gives us 833 over 10, which is 83.3. This is good. It actually came out to the correct rounding. So remember that when we round our data, we always round to one more decimal place than is given in the original data. So since this data only goes to the ones, when we round for our statistics or parameters, depending on if we have a sample or a population, we want to round to the next level of precision, or we want to add a significant figure. Those are synonymous. So for us, having our data go only to the ones means that we need to round to the 10th place, like one decimal. If I had gotten, say, 83 even, it would be appropriate to put 83.0 to specify that additional level of precision. Alrighty, so let's do one with the population. So Professor Lovelace gave a final exam to her stats class, which has 27 students. The following are the final exam scores. What's the mean score? This is a population because we have the data from everybody, right? Everyone in the class. If it had been a sample, maybe we would have taken 5 student scores from the class. But since we have everyone, this is a population. So now we're going to call the mean mu, and we're going to call our size population size, and we're going to denote it with a capital N. Alrighty, so, but again, same thing, same process. So we're just going to add up all the values. That's our sigma x. And when I do that, the dot, dot, dot just means I don't have enough room, time, or patience to write out all the data values, but I assure you I have added all of them up. And by I mean Excel. Excel added all of them up. Thank you, Excel. So we get 1445. Then I need my population size. Again, it's told to me in the statement of the problem, but had it not been, I would have easily just counted up the number of data present. So capital N is 27. Just a little reminder, little n goes with the sample. Samples are little. Big N goes with the population. Populations are big. All right, and then I just do the same thing. I take my sigma x, I divide it by my size of the population. 1445 over 27 gives me 53.51, blah, blah, blah. Again, our data is given to us in whole numbers. So when I round, I need to round to one more decimal place or one extra level of precision, or I could call it one more significant figure or significant digit. Those all mean the same thing. So I'm rounding to the tenths, which gives me 53.5. So next we're going to revisit median. I know we've talked about this so much already, but I just want to review it because it's going to come up later in a more challenging example. So again, median divides the lower half of the data from the upper half. When we have an odd number of data values, the median will be one of the data values given. It's going to be the one right in the center. It's like the middle child. If you have 4 kids in your family, is there really a middle child? I don't know. If you have 3, for sure. And let me tell you, you'll know it. Okay, so here our median is 9 because it's right in the middle. When we have an even number of data values, we have to take the 2 centermost and then take the halfway between them, or the midpoint between them. So the median here is the midpoint between 8 and 9. And we compute that by adding them together and dividing by 2. So we get that the median is 8.5. All right, the mode, I think the mode is the easiest thing. So the mode is just the data value that occurs the most frequently. You basically just look at the data and you're like, oh, that thing's happening a lot. Oh, it's happening the most? Oh, okay, that's the mode. That's it, it's that easy. So if we have this data, you can see right away that 8.2 occurs twice, everything else occurs 1 time. So the mode is 8.2. In this data set, we can see that we have a pair of 11s and a pair of 8s. Everything else only occurs 1 time. So in this case, we actually have 2 modes, 8 and 11. In this last example, everything occurs once. So we don't have a mode, and it's okay to have no mode for your data. All right, so let's kind of step it up in terms of complexity and computation. How do we compute a mean from grouped frequency? So here I have a histogram representing the average amount of hair that gets cut off when a person gets their hair cut. So definitely this is a sample, right? Because I think we have like maybe 50 total frequencies in here. We'll see how many for sure in a second. But the population would be like everyone that gets their haircut, right? This is 50 people, it's definitely a sample. So this is gonna be X bar for us. So the first thing you wanna do is you want to get the midpoint for each class. And so the midpoint is just gonna be taking the lower boundary plus the upper boundary and dividing it by 2. So my midpoints are 1, 2, 3, 4, 5, and 6. And so what I did here is I went ahead and I just labeled the midpoints below my histogram for quick reference. When I constructed this histogram in Excel, I went ahead and had Excel label the frequencies on top of each category, which is an option you can do. And I'll go over maybe more of how to manipulate the finer points of Excel's histograms tricks in a separate video. Alrighty, so now that we have our midpoints and we have our frequencies, how do we use these to compute the mean of grouped frequency? So the way that we do that is we take the sum of the frequencies times the midpoint, and then we divide it by the sum of the frequencies. So in this case, F is frequency, M is our midpoint. So on the right-hand side, I've got my midpoints laid out, I've got my frequencies laid out, so I'm good to go. And sigma FM means take the frequency times the midpoint, multiply them together. Do that for each category. So for the first frequency times midpoint, it's going to be 11 times 1. Then I'm going to add to that 10 times 2. Then I'm going to add to that 16 times 3. So 11 is the frequency of the first bin that has midpoint value 1. 10 is the frequency of the bin that has the midpoint value 2. 16 is the frequency of the bin with midpoint value 3. So you just go on through that until you've gone through all of your categories. Simplify it up. 140 is our total. So that was sigma FM. So again, reminder, sigma just stands for sum. It just says add up all of the F times the M's. This does not say add up all the frequencies and multiply it by the sum of the midpoints. Those are not the same thing. You have to multiply them in pairs. It's like a date to the prom. You've got to take the 11 and the 1, they go together, they enter together, and then they mingle. Not the other way around. All right, so we're going to divide this 140 by the sum of the frequencies. And that's pretty straightforward. It's just exactly what it says it is. It's the sum of the frequencies. So that's 11 plus 10 plus 16 plus 6 plus 5 plus 2. And so we get 50. So now what I do is I take that 140 and I divide it by 50. So I get 2.80. When I put this in my calculator though, it just came out as 2.8 because my calculator is set to float decimal. So I need to be careful to add that extra level of precision. Since I'm rounding, or since I'm getting X bar here, I need to bring it to an extra decimal place. The data given already has 1 decimal place. So when I state X bar, I need to have 2 decimal places. All right, so next up, we're gonna compute median from grouped frequency. It's the same haircut situation. Median of grouped frequency just entails finding the bin that contains the center of data. I'm using the word bin and class interchangeably. They mean the same thing. So we just got to find the bin that contains the center of data. What I did to help me with this was I created a frequency chart. It's pretty straightforward. I just wrote out what the bins were and then slapped a frequency right next to it based on what the histogram shows me. I also created a cumulative frequency next to that, which is really easy, and we've done that before in Excel. Here's why. We have 50 data values. I know that because I added up the frequencies. So the sum of the frequencies is 50. That tells me that there's 50 data values in my data set. When I have an even number of data values, my median is the halfway point between the 2 innermost values. For us, having 50 data values means that our midpoint or our median is the midpoint between the 25th and the 26th value. So where does that value occur? Where do the 25th and 26th values live? Well, they definitely don't live in the first category because there's only 11 there. And they definitely don't live in the second category because by the time I get to the second category, I've only accounted for 21 of my data values. In the third category though, I go all the way up to 37. So since 25 and 26 are numbers that are in between 21 and 37, I'm looking at my cumulative frequency when I say 21 and 37 here. I know that 25 and 26 live here. I'm gonna hit those after the second category, but before I leave the third category. So they're somewhere in that third category. And that's really all I need to know. So once I've located where the middle data values are, all I do is I just take the midpoint from that class or that bin, and that's it. All right, so the last thing we want to do is talk about mode. So I'm going to have two examples. They're both very similar. So if I have the same histogram that we've been working with the entire time, and I want to look at the mode or determine the mode, I just say, hey, what is happening the most? And I hope it's clear that the thing that happens the most is that people cut off between 2.5 and 3.5 inches of their hair. It has the highest frequency, which is 16. So the mode of grouped frequency, we're just going to use the midpoint of the class with the highest frequency. So since the highest frequency is 16, it's associated with the class or bin 2.5 to 3.5. I'm going to use the midpoint of that class as my mode. So that's going to be 3. Let's tweak it a little bit here. Now we have the situation where we have the highest frequency is 13, but it appears 2 times. So in this case, the modes of grouped frequency are the midpoints of the classes with the highest frequency. I like how I'm pluralizing that. Okay. So the highest frequency is 13, that's clear. We need to now determine which categories or bins or classes it's associated to. So that's going to be the 0.5 to 1.5 group and the 2.5 to 3.5 group. So I'm going to go ahead and use the midpoints of those classes. Those will be my modes. So the midpoints being 1 and 3 tells me that the modes for this data are 1 and 3.